All right. Well, happy Monday. We made it. So Project Zero that I forgot to talk about Wednesday because I ran out of time. I got too excited. And none of you reminded me, like, hey, Eric, you've got to tell us what the project is because you didn't want extra homework. I blame you guys. Right? That's okay. So Project Zero, let's start with this one. It'll be due in 2 weeks. So please note 12:30 p.m., the start of class. Right? In 2 weeks, I'm going to go over a solution to this. Once I've gone over a solution, I can't take it late, right? I have people email me, they're like, oh, I didn't come to class, I won't watch the video. It's not that I don't trust you, it's just not fair to the rest of your class, right? So I'll believe you, but I just can't take it because everyone else had to get it in on time. So start early, right? Don't wait until Monday, 12 p.m. to ask me questions because I'm driving. That's a bad time to ask me questions, right? So we'll have time. You can start working on it in lab if you get your lab done early, which is a great time to do that. You can work on it Wednesday. I got office hours. I won't be here this Wednesday. I've got to take my kid to his doctor's appointment. But usually on Wednesdays, I'll be here before class over in the CIS building over that way. It's the one with no classrooms, so you're probably never there anyway. But it's up on the second floor. It's a nice little space. Usually I'll be hanging out there. Or I can also meet, we can do screen shares really easily over Zoom. Just shoot me a message. I'm pretty flexible with my times. And usually I'm up really late at night after I get my kids in bed. So if you like working at 11 p.m. or midnight, that's great because that's when I like to get work done because it's actually quiet in my house for once. So let me know. If you want to work in the morning, it's unlikely. I got into IT so I didn't have to get up early in the morning because I hate mornings and they're just the worst. Which is funny, like we have a whole college for education and human services, and like we realize young people don't do well with mornings, yet we make young people get up early in the mornings and go to high school and have early morning college classes, and we realize this is bad for them, but we do it anyway. You'd think someone would figure it out at some point, that that's a stupid idea, but you know, I'm not in charge of the world, so which is probably a good thing. It would probably not go well if I was in charge. All right, so for Project Zero, again, this is our first project here. So this gives you points towards the project's category here. So when it says it's only worth 10 points and a lab is worth 10 points, they're not the same 10 points, right? All the labs points together add up for your 10% of your lab score. All the projects add up for your 30% of the project score. Right, so it's worth a whole lot more, even though it says 10 points because of the weighted system here. So we're going to plan a little party here because I'm hungry and I want to have a party. And then I will show you, we're going to add screenshots to the README of it running. It's super easy to do that, but you just haven't seen how to do it yet. So we'll actually practice that in lab today, running some screenshots. I'll show it up here, but we'll practice it more in lab as we go. So you're going to turn in the URL. The only thing you submit is the URL of the repository, just like we did for our first lab. But we're going to put the screenshots into the README file on the website. Okay? That way, like it's just a picture of it running. It makes it nice and easy for you to look at it there. And it's your chance to make sure it actually runs. I don't know why people turn in stuff to me that doesn't run. Boggles my mind. And it's really hard to score stuff that doesn't run. Like I try and give partial points here and there, but if it doesn't run at all, it's really hard. Anyway, so we're going to write a program that helps a user plan a party. That's the problem we're trying to solve here. Right? We want to figure out how do we help them plan a party here, because it's a big party foul to not have enough whatever you're supplying, right, for people who come to your party. Okay, so the first thing we're going to do is ask them for their name, and we're going to use that in all of the following prompts because we want our computer to pretend like it's very nice and friendly. So we'll say, hey, what's your name? And then every time we ask them another question, we'll say, your name, what, yada, yada, yada. Your name, yada, yada, yada. Your name, yada, 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 right? So whatever they type in, if they type in Eric, it'll say Eric. If they type in Bob, it'll say Bob. If they type in Fluffy Bunny, it'll say Fluffy Bunny, right? We don't care what they entered. Just whatever they gave me for their name, that's how we're going to address them here. So we're going to ask them how many guests they expect to come. So we'll be looking at different types here, doing those conversions. We should be fine here. So we're getting into chapter 3. And then we're going to ask them, what are they serving at their party? Pizza, drinks, or ice cream? Right? So if they're serving drinks, then we'll do a certain thing. If they're serving ice cream, we'll do a certain thing. If they're serving pizza, we'll do a certain thing. And we're just going to assume they're only serving one of those because otherwise it gets a little trickier. Okay, so just one. If they want to do both, they can run it more than once. So if they're serving pizza, ask them how many slices the average guest will eat. If I'm inviting my teenage son and his friends, they're probably eating like 6 slices apiece because he's 16 years old and eats ridiculous amount of food. So I'm going to need to buy a lot of pizza. If I'm inviting my 10-year-old daughter's friends, they're probably only going to eat 2 slices each. She just doesn't eat a lot, right? She's kind of small still. So right? Ask them how many slices come on a pizza is the next question then. So if you eat this many on average, and then if you're buying smalls that only have 6 slices each, sure. Or if you're buying larges that have 10 slices, or mediums that have 8, or whatever happens to be, right? Maybe you want to buy a ridiculous pizza that has 16 slices. I don't know, go for it. Whatever number you give it, you could say 7. Don't worry that it's almost impossible to cut a pizza into 7 slices. That's not our problem, right? That's wherever you ordered it from, right? Great. And we're going to calculate how many whole pizzas you need to order. You can't order 3.5 pizzas. The pizza shop will be mad at you when you say, I want 3.5 pizzas, right? They're going to think you're stupid, right? If you need 3.5, you have to order 4, right? Okay. If you need 3.0 exactly, you only have to order 3. Right, so we're rounding up, right? Some of those mathematical operations we can do. Remember we looked at there's like floor to round down, there's seal to round up, which is short for ceiling. I don't know why they didn't spell the whole thing out, but 3 extra letters. Sure, we saved a lot of typing there. So seal will do the rounding up for you. And that's your hint there. And then ask for the cost of pizza. Display the total number of pizzas and the total cost. Okay. So here's what you need to do. Go buy this much, and it's going to cost you this much for your party. Great. Same idea, but things are a little bit different here. So now, if we're doing drinks only, pop, right, because we live in Michigan, we don't call it soda. Otherwise, you're going to get kicked out. You got to call it pop. Ask them how many ounces each guest will drink on average. If each guest drinks 16 ounces, great. If they drink a 12 ounce, great. If they drink whatever, how many ounces are in a 2 liter? I can't convert that in my head. Sure. It's like 2 quarts, right? So it's probably 64 ounces around. Then we're going to calculate the number of whole gallons, not 3.5, because we can buy pop by the gallon in our little scenario here. It doesn't have to make sense. It's okay. We'll just pretend that you can buy by the gallon here. And then ask for the cost of each gallon and display the total number of gallons and the total cost. Right? Same idea as pizza, but now we're doing it with drinks. So there's a little bit different conversion here. Remember, there's a ounces to gallons ratio. Is it 64? Right, 32 ounces in a quart for those. No, it's 128 then in a gallon. Ounces in a gallon. Look at that. Search suggests 128. I got it right the second try. Sure, that's fine. Okay, and the third option, ice cream. How many scoops will each guest eat on average here? Or like you're making cones or bowls or whatever here. Think back to your stats class, right? We have combinations, we have permutations. Not that that matters at all, but when you get your cone, you have permutations, and you have your bowl, you have combinations. I still remember that to this day as like my favorite piece of math trivia. It's ice cream. And I always think of ice cream now, and it makes me hungry when I do stats. Well, so how many scoops come in a container? Because I don't know, they're like 1.5 gallons now, or no, 1.5 quarts now. They used to be half gallons because I'm an old person. I remember that. And then they started shrinking the size of ice cream containers, and it makes me sad. But you can still buy the big gallon tubs if you want. Yeah. Right? But that ice cream's never as good. It's not as good as the good Breyer stuff. And then you calculate how many whole containers, again, not 3.5. I copy-pasted, can you tell? They need to buy, ask for the cost for each container, and print the number of containers and the total cost. So we're doing the exact same thing, just with different words, right? Different formulas here each time. Right? And then for the rubric here, I will use this for scoring. If you ask for their name and you use it in the prompts, you get 2 out of the 10 points. That's the only thing you do, you get 2 points. You don't have to have anything else working, but you get 2 points. Right? If you ask for the number of guests, you get 2 points. Sure. You probably need to store that somewhere. I think that kind of goes with it here. But if you ask how many people are coming and you just ignore the user and say that it's always 10, I guess you still get the 2 points because that's what I put in the rubric. But it should probably actually use that number here. And then calculate pizza correctly, drinks correctly, ice cream correctly, 2 points each here. So 10 points total for this. All right. Yeah.
So they're only able to pick one?
Yes.
Like pizza, drink, or ice cream?
Yep. If they want to do a second one, they can just run it again.
Oh.
Yep. Otherwise, it gets much trickier in our program. Right. And not everyone's going to serve all 3 things or anything like that. So we are going to need chapter 4 once we get there next week to figure out how I do, is it this one or this one or this one, right? For what are they serving, right? If they want pizza, I only want to do the pizza thing, right? For right now, if you just wanted to start doing all of them, you can do that. And then later we'll figure out how to make it only ask for one of them based on what they said they're serving here. But we're not there yet. That's okay. So that's probably what that note meant. I think I copied this wrong here. Let's move this down. This part needs chapter 4. Okay, we'll fix that here. That's my bad. So again, we can go back to it. We got some time here, but most of this we can get done. We can do all the arithmetic now, right? We know how to do arithmetic. Does that make sense for Project Zero? Okay, cool. And again, it's a new GitHub repository. So you click the link, it'll give you CIS 1501, fall 2024, Project Zero dash your username. You clone that, have the copy on your computer, make the project in that folder. We're going to do it for every lab. We're going to do it for every project. By the end of the semester, you'll be sick of it. And you'll probably actually know what you're doing back then without having to look at the videos by the time we've done enough of these. It's okay. This is our second one, so no worries. Almost out of coffee. I'm really sad. I'm going to make it to the library to get the free coffee here. Definitely. It's Keurig coffee, but it's still hot and black, so it counts. All right. Moving on to Chapter 3. So all sorts of different types here, which is fun. How are the labs going, by the way? You're all working and got these done, right? Because we moved on to Chapter 3 already? Everyone's there? Okay. You can lie to me. It's okay. I'll check later. If you have...
But I started on both of them.
So how much time does it take to get one of these done? Is it like 5 minutes, 10 minutes, an hour?
A section or a chapter?
Per like for a single lab.
Oh, for each one?
Some of them are less than 5.
Okay.
Yeah, so
Yeah,
it's
The
that's
longest
fine.
one I've done is like 5 minutes.
Okay. So, but still, if you have to do 5 of them now, we're looking at, it's probably going to take you at least half an hour?
Yeah, half hour.
20 minutes, half an hour?
Depending on the-
Okay.
They're
So-
simple. They're just
Yeah.
take time because there's a lot of sections.
Yep. And they'll get more complicated, just like a math class. Everything we learn, we're going to keep on using forever. You don't get to forget anything we've talked about. We'll just keep using it for the rest of your life, basically, every time you do Python here. You might not use modulus every single time, but occasionally we'll use modulus. All right, yeah, so do keep on track with the Zybooks. Right? You're in for a bad time if you leave it for the end of the semester, because then you just have no time to click through these things, and they do take time. And then you have other final exams to study for. I'm just trying to keep you on track here. Not enough to actually run and score it every week, because that's a lot of time that I would have to do. But for you, just try and keep up here. We got 20 people subscribed. Okay, pretty good. I think we got almost everyone in the class now. So I can click this like little report button here, and it shows me, like, hey, 34% of the people got Zylabs done. 43%, 49% of people actually like looked at Chapter 1 and did all the different exercises here. So this is the sort of thing I'll do at the end, but it actually attaches your name to it, right? But I can see who's kind of keeping up here. A couple overachievers already got into Chapter 3. Good for you. Or maybe you just opened it just now. Maybe. I don't know. 5% of Zylabs. That's great. So the optional chapter, I'm not going to score that one for you. It's optional there. And then additional materials is also optional. You paid for it, so I gave you access to it. But it's just extra stuff there. I think this one's more Zylabs, right? Yeah, tons of extra labs. Some of them I hid. There's just too many. But all right, let's go back. Chapter 3. No, I'm in the wrong view here. My class. There we go. So we start up a new PyCharm project here. New project. Again, I'm putting it in my repository folder here, right? Just make sure it goes into whatever repository folder you're working on. If you don't want to put it in the repository, you can just put it anywhere you want. Doesn't matter. If you want to just keep dumping all of your stuff into the Lab Zero repository, have at it, right? You can. There is a limit to how much you can put in there, but you probably won't hit it unless you're trying to store movies and pictures and stuff. But you can put as much code out there as you want, and you're not going to run out of space on the Lab Zero one. So if you'd like to have another copy out in the cloud, go for it. Just a fun fact, because Microsoft owns GitHub, if you put it in your OneDrive folder and on GitHub, Microsoft now has 2 copies of it they have to manage, and you're wasting bits out there. So you should feel bad about yourself. But OneDrive is fun, right? And that automatically syncs versus GitHub, which is the manual I have to commit and push syncing process. So you got that. All right, so this is Chapter 3. Again, virtual environment, great. It's a good habit to get into. If we're not really going to do anything that matters too much here. And then I love the main PY script to get started here. I should have updated PyCharm. I forgot. I'm going to get the latest version next time. I think there's one other checkbox you guys have. All right. And again, I don't actually like any of the stuff in here. I just want the file already created so I don't have to go make my own file. It just saves me a little bit of time here. Bless you. I'll zoom that in a little bit. So all the different types. This is going to be just a lot of different things here. Lists and tuples and sets and dictionaries are super fun, interesting ways of storing information. It's going to take some practice. So we'll get there. We're kind of introing them, and then later on we have a whole chapter on lists and dictionaries. Right? We'll do more interesting stuff with them. We're just kind of getting started here with these. But for strings are just a bunch of characters strung together. So I call them a string. Right? Here's a character which you looked at, which is really just a numeric value. It's that Unicode value, and you string a bunch of them together to make some sort of whatever, all the characters you want here. That's why we call it a string. When it's in our program, we call it a string literal. Like we've hard-coded it into the program here. So name is Eric. This is a string literal here because it's just coded right into my program here. If I have, last name is an input of enter your name. Enter your name is a string literal here, but whatever value I'm getting back here is going to be stored as last name. Now, really, it's variable. It's whatever they typed in, we're taking here. Name is, we still call a variable, but it's always Eric because I've hard-coded it into my program here. So that's what it is. So when we create strings, right, it stores at the first position is index 0. We always start counting at 0 because that's the right way to count. I don't know what they taught you in elementary school, but you don't start at 1, you start at 0. When I tried and told my kids that, they really got confused. Apparently, young kids don't actually understand what 0 is because it doesn't mean anything to them until they're like old enough can understand these abstract concepts. Everybody understands 1, but it takes a while to actually learn what 0 is. That's a fun one, but we're going to start at 0. So if you want, you can get an individual character out of your string here as you go by index. And we can see the length of a string using this len. Again, we saved a couple letters, length, len for length. You can see how long that is here. So we can say print your last name has, and then comma, right? If you want to print out more than one thing, we just comma separate them here. Length of last name, letters here. Right? Not very interesting here, but enter your, I should have said last name here, 9 letters, right? Enter your last name. So Chernesky has 9 letters. Right, that's a long last name. My poor kids have a hyphenated last name, so they have 15 characters. But it's okay, that still fits. 15 fits on most forms here. So we can get the length of a string out if we want. Now, each individual character is at a given position. Now this alphabet one is fun here. So you can get out an individual character by using the index. So what position is it at? And we always start at 0 here. So 0 is going to be the first position as we start at counting 0. So that's A. So alphabet of A, this in the square braces here, I call like index of, is what I would usually, if you're trying to say this in English, it's alphabet index of 0 or at 0, however you want to say that. So that's A, index of 1 is the B, index of 25 is Z. So we get A, B, Z, right, when we run this one here. I'll just do Eric again for last name, right? We get individual letters A, B, Z, right? So if I wanted to spell Eric here, right, E is at index 4. Alphabet index of the R is, what is that, like 18 or something like that? It sounds pretty close here. I'll check it when we get there. I is 9, I think. Might be 8. And then alphabet C is the second index here because it's the third character. We'll give it a try, see if we got close or not. Okay, so P, Q, R, S, so 1 too many. Right, that's okay, so we'll go down to 17. And then J, 1 too many again, so 8. I was close, right? I was close. Now we'll run it again here. Chernesky, can't spell my last name right, that's okay, but I get all my letters out for Eric. So we can use these indexes to get a single item out at a given position. Not super fun, but this is going to start setting us up to do more interesting things later. Right? So I can use a string and I can get out individual characters. Now, you can get them here, but you can't set them here. So if I wanted to change alphabet, I can't say alphabet index of 4 equals, let's put it back to A. It's going to yell at me here. Okay. Now I just get some warnings here saying class str, str for string, does not define under, set item, under. So the square brace operator cannot be used on its instances. That's the technical explanation here for why this doesn't work. Now, weirdly, it's just a warning here. I can still hit run, and then when I get to that line, now it crashes. Now it says string object does not support item assignment. You can get values out, but you can't go change them. You can't set them here. So in Python, we say strings are immutable. Immutable. Immutable? Mutable? Immutable. You can't change them. Once you set what the string is, it's stuck. So what that means is when we create this string, Python says, hey, operating system, I need a place to store 26 letters. And the operating system says, sure, here you go. Here's a place to store 26 letters. But now I can't go change what's stored at that location in memory. So if I want to change the value of alphabet here, we could. I can say, hey, alphabet, let's do this backwards here. So Z, Y, X, W, V, U, T, S, R, Q, P, O, N, M, L, K, J, I, H, G, F, E, D, C, B, A. That was fun, right? We can go set it to a new value here. What this does, when Python gets to this line, it says, oh, hey, you want a new value here? Hey, operating system, I need a place to store 26 characters. Gives me a new spot in memory. And then operating system gives it a place to store the values, stores it there in memory, and now alphabet points to that new location. So it was looking over here at A, B, C, D, E, F, G, and we said, hey, I want to store it backwards. So now it says, okay, don't look over here anymore, look over this way. And what happens behind the scenes is eventually this spot that was stored in memory, Python has this thing called a garbage collector. Its process says, hey, you're not using this anymore, and it will go tell the operating system, hey, I don't need this memory anymore, you can have it back. So it's a way to make sure that we're not hogging all sorts of memory. I don't know if you ever run Chrome. Chrome is garbage, by the way. It's like basically spyware. There's a whole article about it. It's awful. If we're not using the memory, the operating system can take it back and use it somewhere else. But something like Chrome, it only ever grows in memory usage because it sucks, right? You'll see, oh, now I'm using 500 meg of memory. Now it's 600 meg of memory. Now I'm at a gig of memory. Now I'm at like 3 gig of memory. And it just keeps on eating and eating memory. It's not good. So garbage collection, this process of making sure my program doesn't use up all this memory. It's pretty easy in Python because Python takes care of it for us. Other languages like C++, you have to be a little more careful with it and manually manage your memory, which is awful, and it's really tedious and it's obnoxious, really, really annoying to have to do. So it's nice that it's managed for us. So Python manages that for us. Just a fun fact. So I can set something, change it, set something, change it, set something, change it, and it's not going to leak memory or just keep on eating and eating and using more and more memory here because it'll get taken care of for us, which is nice. But I can change the value, makes a new location in memory, right, for alphabet. And again, now if I do this, it's not going to be Eric anymore because we've changed the order. Right now it'll be, I don't know, whatever that is here. Well, the I is still the same. That's fun. And the R. Okay, so 17 and 8, they're flipped, right, from 25. That's fun. But you get other letters here, right, because we changed it. Now, doing this one at a time, not all that interesting, not super helpful here. But you can do that sort of thing, right? You can get out individual letters here, and that has you go through the exercise here. You can concatenate strings, so you can take one string and you can take another string and stick them together to make a new string. So earlier we did print 5 plus 4, and this works, right? That's 9, right? Or I could print 5 plus 4 in quotes here. What do you think I'm going to get with 5 plus 4 as strings? 54. It's the concatenation. It's going to say, okay, here's a string, stick them together. You must want one string. So now we get, right, 5 plus 4 is 9, but quote 5, the character 5 plus the character 4 makes 54 as strings here. So we can concatenate these things together. So, or if I wanted, I can print hi, and then if we're concatenating here, I would use a plus. I have to do my own spaces. When we do comma separated values, it adds spaces for you. But when you concatenate, it doesn't add spaces because it just says, oh, stick them together. So we got to be a little careful with this. So I can say hi, name, plus another space, plus last name here, right? So I'll get the literal hi space, whatever value I stored as name, Eric here, another space, whatever value I stored as last name, whatever they typed in here. So we can concatenate those together here, and now we get, hi, Eric Chinesky. It's so nice. The reader knows who I am. It's very friendly. So as we're doing our prompts here, right, we're saying, hey, enter some values here. I need to do some concatenation, right? When I'm using inputs here, right, let's like say favorite color equals an input of, I can't say name, comma, what is your favorite color? And notice it's just highlighted right away, unexpected argument. It's not the most helpful error message in the world, but it's saying, I don't know what to do with this, right? When we get to here, it's going to crash on us. Input expected at most 1 argument, got 2. When you comma separate things, it treats them as different values here. So that's sort of a helpful message. Doesn't mean a whole lot. I mean, if you're not sure, go Google it or ask, and eventually you'll see it enough and you'll know what it means. So if you want to use name in a prompt here, we have to concatenate your, I can't spell your either. There we go. So name plus, so we're going to take this string and stick them together here, right? And because of order operations, they're inside the parentheses. That happens first. Then it gets handed to input, and input will spit out one thing, right? It says, I want one argument, I want one thing. I only want you to give me one thing. I don't know what to do with 2, right? So we'll turn it into one thing with concatenation. Now I get, Eric, what's your favorite color? And I can tell it blue. You know, I didn't do anything with it, but now the prompt works. So as we're working on that project here, we need to, all of our prompts then will be based with this. The other way you can do it, if you don't like concatenating here, and you want to do more, that's fine. You can also say print name, what is your favorite animal here, and then I can say favorite animal is an input with no prompt. So if you have no prompt here, it doesn't show anything. But if you print something first, that's what's showing, and then we're waiting for input. So it's effectively doing the same thing, and then you don't have to concatenate, you can comma separate. Just comma separate, concatenate. Does that rhyme? Separate and concatenate? Sounds like it does. All right, so favorite color, blue, favorite animal. Now, I'm on a different line. Looks a little bit different here. This is actually a little bit ugly to have a prompt right at the end of this and they run together. It's not the prettiest thing, so if you like things to be pretty, maybe a colon and a space here. Or you could even add in your own new line characters, when we could do that /n, those literals. I like it to be on the same line. Some people like it to be on the next line. I don't really care. I like giraffes, though. All right, great, and now I'm done. Program finished. So I can do those with concatenations here versus my comma separatings. String formatting is super helpful. So this way I can substitute values in. This is even easier than doing it this way. So I can use a formatted string or an F string, so that's really tiny here. But instead of even having to concatenate here, you can string format. So let's do I did favorite color, I did favorite animal. How about favorite season? Is an input of, now I'm going to make a string, and before the string starts, I'm going to put an F to say, hey, this is a formatted string here. These are super common and very helpful. So instead of having to say name plus this and do all my spaces and things, I'm going to use curly braces because, sure, we probably never print curly braces in real life, right? If you want one, you'd have to escape it, right? But sure, we're fine. And now I can say name. And notice name shows up in white, not in green. I don't know, if you're colorblind, it might be hard to see. But anything in green, PyCharm is saying, hey, that's a string literal. I recognize that's just a bunch of characters, a bunch of text. Because it's not in green, it's automatically going to be substituted in here. Because the magic of these curly braces and a formatted string, we told Python, hey, when you get to something in curly braces, go grab that variable, stick it in here for me. I don't want to have to concatenate it myself because I hate typing the plus character, which is fine. It's a little harder to reach than the curly braces, sure. So name, comma, what is your favorite season? And then again, maybe a space here. I don't know, I guess those should be question marks, right? That's because those are questions we're asking. And now when I run this one here, so last name Chernesky, I can't spell, that's fine. Blue, giraffe, and fall is my favorite season here. But notice the output here is almost the same every time, right? It's the same as the first one here with the comma. So this should be comma, what, right? Now this one's actually going to look a bit ugly here. We'll see, because when I run it one more time, Chinesky, blue, giraffe, notice there's a space here, right? Because we comma separated in print, we got spaces. So it put a space in, and then I put my comma in. So it looks like we don't know how to type, right? Because it shouldn't say Eric space comma. That just looks really awkward, right? So this is tricky that way, right? But the formatted string looks really pretty, and I think it's easier than trying to concatenate stuff together, right? What's your favorite season? So formatted strings are really nice and helpful and friendly here. And again, fall, and great, our program's done. So you don't have to do all this concatenation work. Older programs, you'll see a lot of concatenation. The formatted string is relatively newer, not super new. It's been around for years already. But changing code is expensive, right? If a company paid someone to write some code for them and they're using that program, they don't want to pay someone to go and change it to use a new thing and not do anything different. Like, why would I go pay $1,000 for someone to update a program and not have it do anything different, right? That's just a waste of money, right? Companies want to make money. That's sort of why they exist. So they're going to do things that make sense and not pay money for no gain, right? If they're getting something out of it, they'll probably pay some money. So you won't see these in all Python programs, but newer Python programs you'll see these in. And then some people just don't like using them. Some people like doing concatenation. Sure, it's really just a style preference. Whatever you like to do, go for it. I find this one the fastest and most easy to use here. It takes a little practice, but you can throw them in there. It should be fine. Let's see, so we got alphabet, we got name, and then the other fun thing we can do here, let's do favorite number. Now remember, we're dealing with numeric values. I need to convert them if I want to do any arithmetic. So I need this to be an int of an input of a formatted string of name. What is your favorite number? Oh, and notice it's red here because I misspelled name because I can't type. There we go, name. Right, so now I have an integer. Now I can take favorite number though, and we'll just do one more output here. Let's just print a formatted string of names backslash apostrophe. If I wanted to show an apostrophe here, it's one option. I didn't end my quote. Favorite number is favorite number. Eric, oh, last name, sure. Color, favorite number, let's do 42. Season doesn't matter. And now we get Eric's favorite number is 42. It will take this value that's an integer and put it in right away for us, which is pretty nice. So it will say, oh, you want it in a formatted string, you probably want the string version of that for me. You probably don't want the numeric value, you want it to be a string, which is fine. If we did, let's just do name plus favorite number. Oh, favorite number. I wanted name, sorry. Name plus favorite number. Maybe plus a space here. Plus space. Right. So favorite number is comma separate. Nope, sorry. We're concatenating here. We're trying to concatenate everything. Notice it's highlighted here, right? When I'm trying to concatenate now, it's saying, hey, unexpected types. Type int, possible types string. Saying, I found an int, I didn't expect an int. If you're concatenating strings, Python would expect a string here. Right? And then Chinesky and blue and giraffe and 42 and fall, and now it crashes. Right? Can only concatenate str, not int to str. So not only does the formatted string let you take things that aren't strings and replace them in, it saves you the hassle of trying to remember, oh, this one is a number value, so I need to comma separate it in a print versus that. Right? It's just all around easier here. Right? So this will crash. Can't use string concatenation, plus sign, with non-strings. Does that make sense? Right. Okay. So string formatting with F strings, you can do some cool stuff. Other fun things you can do, you can, where is this one here? You can do arithmetic right in your string formats. So inside of the format, I can say, hey, favorite number, plus 10. They're kind of treated like parentheses. Right? They're curly braces, they're like special parentheses, I guess, but it will do the arithmetic first and then substitute it in. So that's one option here. I'm going to leave that out because that changes my favorite number. And then you can format specify. You can give it a specific type here. So this is fun. Remember we wanted to look at, hey, the value pi rounded to a certain number of digits. Now we actually look at how you do that. So I didn't come up with this, but if you're using integer values, you use D for decimal. I don't know why. If you're using floating point number, you use F for float. So this one makes sense. D for integers doesn't make any sense to me. You just have to go look it up here, or just remember that Python's crazy. So if you want a number with a whole number, not a floating point number, you give it D. And then it's cool, you can even add like a digits grouping. So you can say, hey, I want a comma D here, and it will automatically add in your thousands separator here, which is fun. So we could print some big number. Let's just have them enter. So some big number is an int of an input. Enter some really big number here, and then we could print it back out as a formatted string here. I want some big number, and then to do the formatting, you give it a colon, still inside the curly braces, and I'm going to say, hey, I want comma D for digits, decimal. It's an integer. I don't know why, but sure. And then so it'll print it back out with your format specifier here. I should have put that at the top. Now I don't have to type all this stuff. 1, 2, 3 seasons. Oh, I forgot this is going to crash. I'm going to leave that commented out for right now so it doesn't ruin my program. 3. All right, so some really big number. So just shout out some digits. I'll start typing them in. 2. 4. 10. 7. 8. 3. I need a lot. 4. 9. This is as exciting as it gets, I'm sorry. I need more digits. 2, 20, 6, 5, 4. That's probably big enough now, right? And now we get it back out with the digit separator here. All right, so we had 241 trillion, 78 billion, 349 million, 220,000, 654. Nice. But again, it gives us the digit separator by default. Now, when you're asking for a big number here, let me do SDF a couple times here. I can't give it a digit separator. If I do that, Python gets really upset. It says invalid literal for int with base 10, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3. It doesn't take it, right? So when you're asking for numeric input, you can't give it numbers with commas, which makes it a little confusing if you're like trying to give it a really big number and tracking it yourself, right? So it'll crash. So you can format it back out this way, which is nice. And I think we looked at, we needed math, right? So if we're going to import math, nope, not a breakpoint. Goodness gracious. Up here. There we go. So import math. Now I can use all the math stuff. We could print a formatted string of math.py, right? And now a floating point number. And if I want 0.3 or 0.4, I'll get 4 decimal places. Don't bother memorizing it here. It's you don't need to. Why did it not like that? Missing a space. Okay, colon space. That was a warning. So I want it as a floating point value with 4 digits after the decimal, right? I should have 1, 2, 3. Nope. Really? Did I do it wrong? I did. What did I do wrong? F. Oh, it's backwards. So the F at the end here. That's what I did wrong. So it's 0.4 F. There we go. I can never remember. It's not worth memorizing. Color, number. All right, there we go. So now I get this to 4 decimal places. And notice it's rounded, 3.14159. so it rounded up the 5. So just be careful, this does round. Does round at the last decimal. Okay, that's fun. And then if you also want commas, it's comma, dot. You can get commas here. And you can also add in something to the left of the decimal place here. That one's a little weirder here. Let's try that. 2, 3. I should have put these at the top. Oh, it didn't. No, I'm sorry, it didn't do that for me. There's a way to get something to the left of the decimal. I forget. You can like pad numbers out to a certain thing. If you want scientific notation, exponent notation, you can get that. 6 places of precision, sure, that's fun. All right, so all sorts of formatting. Just go look it up, right? Or just go ask ChatGPT, hey, how do I format this? That's probably your best bet. All right, so if we were to do that, so let's go to our GPT tool. We'll figure out how do we do padded on the left here. So how do I get extra left digits? Left the decimal digits to show in Python. A formatted string. A formatted string. It's nice that it shows you my whole history here. That's handy, right? I use it for letters of recommendation because it's really easy. Like, I'll be honest, it's fine. Padded spaces, leading zeros. One of these here. Yeah, okay, so yeah, in Python 3.6 and above, you get the formatted string with the F string. So if when they started Python before 3.6 came out, they wouldn't have been able to do that. You could use str.format, and you could give it a string and then call .format. I hated doing it this way. This was the earlier to 3.5 way of doing it. That was a bit obnoxious. All right, so if we want, make sure there are leading zeros up to a certain digit here. We want this one before the decimal place. Width of 9. Okay, so let's try this. And because we got this from ChatGPT, right, I'm going to put in my little comment here. And I'm going to go to include the prompt, right? I don't have a link to the conversation like OpenAI does, so I'm going to include what I asked it, right? Okay, now I've cited my source. Life is good. There we go. Okay. So 0, oh, okay, so 0, 9, is that 9 digits total? I don't know why it's a 9 there. Up to a certain digit. Oh, with the width of 9, yeah. So the 0 padding, 9 total digits, 3 decimal places. Sure. Well, just ask it. It'll come up with it for you here. But we can do that sort of thing. That was worthwhile, right? Yeah.
So are we only allowed to use the GPT or can we use it?
You can use any of them. So UMGPT gives you version 4 versus OpenAI's 3.5. I don't know if they're doing the beta of the 4, if you had to pay for it. It changes like way too often for me to actually keep up with it. And then there's other versions too that like Claude is pretty good for programming. There's a couple other good ones one of my colleagues likes for things. But yeah, so if it's got a link to the conversation, you can give me that. If it doesn't have the link to the conversation, I'd like to know what you asked it for. And if you prompted it 3 different times, give me all 3 prompts. Like, here's my first question, here's my second question, here's my third question, right? That's just so I can follow it here. And again, you can use it for parts of things. You can't just feed it Project Zero and say, give me this, and then turn it in and say, hey, I got my solution from ChatGPT. You'd fail an English paper if you gave it one giant quote, right? So if you're like, hey, ChatGPT, how do I make sure that I only do one of these 3 things because I didn't want to get to the next chapter yet and I'm lazy or wanted you to solve it for me, you could give it that piece, right? I don't recommend that, but sure, that's an option, right? And just cite that source, okay? And also you can't get the solution and then paraphrase it either. You can't turn in one giant paraphrase, right? That's still not your work, right? Paraphrasing something doesn't count as your own work. It's still citing a source. Right? For English papers, you still have to do your own writing, your own sentences. Okay, you've taken composition classes, that's good. We're good at that by now. High school must have been really fun with ChatGPT. It's been real fun. Okay. So strings, okay, so moving on to some more interesting types here now. So we did strings, so lists, tuples, sets, and dictionaries are collections here. Now, a string really is a sequence or a collection as well. It's a collection of characters here. So a string is very much like a tuple, but it only holds characters. So let's look at, we'll do lists because it's the first order here. So what a list allows you to do is store a list of things, more than one thing. Now this gets a little silly here, but that's okay. So we'll say this is, how about we have a list of foods. With a list, you use square braces for lists, okay? Now what I get to do is I get to put as many things as I want in this list. So we'll give it my favorite foods. We'll do apples and bananas and cucumbers, and I can't think of donuts. All right. So now I have a list of foods here. Oh, it doesn't like my spaces. I like spaces. Python doesn't like my spaces. Okay. So I have 4 things in my list here. Now guess how I'm going to get out each individual item? Remember how we got out individual characters? We use the index here. So the first item is at index 0. So I can print foods at 0. That'll print the first item. So first item is at index 0. Just like with strings, right? The first item in the list, we get at index 0. So I can print, and I get apples. I got my first item, right? I could print foods index of, now if I say 5 or 4 here, because I count 4 things, but I forgot to start at 0, I get a index error, list index out of range. So this will crash here. Nothing at index 4 here. I'm going to comment that back out so it doesn't actually crash, but we can't do that. It doesn't exist. We don't have a 4th index, right? We have 0, 1, 2, and 3. That's all. So let's put it this in here. So this is 0, 1, 2, and 3. Is that helpful? Index. Sure. Okay. So first item is at index 0. Move that down a line. So that's my list. So lists, though, are mutable. Lists can be changed. So if I want here, and I said, oh, I don't like apples anymore, I want to change that here, or maybe I want to be specific here. So I'll say, instead of print, I'll say foods at index 0. Now I can assign to a specific index. So indexes are assignable because it's mutable. Because it's changeable, you can change what's there, right? We can give it a different value. So how about we say Gala apples? Those are one of my favorites. Or Honey Crisp are the really good ones, right? Honey Crisp. It's almost Honey Crisp season. I think are the cider mills open yet? Like you can go and you pick apples? Nice. I've got an apple tree in my front yard that's been doing really well. The back one, the deer keep eating all the apples, which is fine. It's good to feed the animals, I guess. But so, oh, I didn't print it back out here now. Print. And then if you want, you can actually print the entire list all at once here. We could print alphabet, right? It would print out, we've printed whole strings before, right? With list, you can also print the whole list. So let me go, I get the first one, right? I get apples, and then I go and change the value to Honeycrisp apples, and now when I print foods, it looks like a list, right? It prints out basically like we gave it, but now, right, I've substituted Honeycrisp apples with apples. So now I have Honeycrisp apples, bananas, cucumbers, and donuts, right? So you can change the values at your given indexes because lists are mutable. The other fun thing you can do is you can add to it. Is that even in here? I think it's in here, right? Let me see. Accessing, updating, adding and removing. There we go. Append lets you add something to it. So the syntax gets to be a little bit funny here. So if you want to add something to the list here, maybe we'll ask the user, right? We'll say favorite food is an input of, and then we need a name. Oh, I don't even have name yet, so I can't use name. Right? If I try and use name plus what is your favorite food? Oh, that should be a formatted string, right? Because those are better. Formatted string. Curly brace, and I don't use my pluses anymore. What's your favorite food? Now I started with a single apostrophe and I ended with a double or the quote marks, right? You gotta mix it, you gotta match them here. But now name shows up as red. It says unresolved reference. That's the fancy term for it doesn't know what name is. We haven't got there yet. We didn't tell Python that name existed till line 30. you can't use something before you tell Python about it, right? Like if we're to ask you, hey, what's my son's name? But I haven't told you what my son's name is, you wouldn't be able to answer the question, right? But once I tell you, hey, my son's name is Jeb, and I say, hey, what's my son's name? You can tell me Jeb, and I can plug it in here, just like that. So I can't use name. We'll just go back to what's your favorite food. And now you can use formatted strings without formatting. It's just silly, and you did more work than you needed, but that's fine. Then I'll take my foods, and I'll say foods dot. So foods is the variable that I'm storing the list in. So foods dot gives me all the things I can do with a list. So I can insert, I can remove, I can append, I can pop, I can clear, I can index, I can copy, count, extend, reverse sort. Those are all fun things here. We want append here. So what are we going to append? What do you want to add on to the end of the list, right? Appending adds it on to the end. Let's add the favorite food. And then we'll print foods again. So we get a run. We get, what's your favorite food? What should we add here? What are you guys feeling like? Yeah, fish. Now we get Honeycrisp apples, bananas, cucumbers, donuts, fish. Awesome. Right? It just appended it, it added on to the end of the list. So you can add stuff. So because lists are mutable, you can add essentially as many things as you want here. I don't even remember what is, right? What is the max list size in Python? Maybe length. Let's see. How big can a Python list get? Looks like we can have, what even is that? 536 million items in a list. That's my guess here. Oh, but that's a 32-bit system. We're on 64-bit systems. We should be able to get bigger than that, right? Max size, I don't know. None of those answers are handy, but really big, right? I don't know the exact answer. That's probably not all that important, right? But you can add lots and lots and lots and lots of things. After a million, I don't really know what you're doing anymore with your life. Right? But you're probably not doing it one at a time. Right? At some point, you're probably processing a large data set. And when we get into actual doing data science, later on, we're not doing real data science in this class. I'm sorry to disappoint here. But once you've learned a bunch of stuff, then you can actually do the cool things here. Right? We're like, here's your training wheels. We'll get you started here. Then you might have millions of things in a list. And maybe you worry about, am I going to hit 500 million or not? Maybe. It depends what you're doing. We're fine. We can append and append and append and append and append until we're blue in the face, and we won't run out of space. Okay, so we can append things in the list. If you want to remove something, you can remove a particular value here. So we'll say foods.remove. Now, remove is by value. So what value do you want to remove? Say, oh, hey, let's get rid of cucumbers here because we forgot them in the garden and they got too big and now they're sour. We don't want to eat them anymore. They get gross if you leave them too long. So cucumbers here, and then we'll print out foods again. Stop and run this one. Let's add some fish again. And now we see we took out cucumbers, right? But now if I misspell it here, or don't even have the same casing, right? Python's very case sensitive when it comes to strings. So if we add fish, now it crashes on me. Value error, list remove X, X not in list. And think back to math class, well, X is cucumbers. You can't remove something that doesn't exist, right? Yeah.
And so when you put cucumber, instead of putting cucumber, can you put the index?
So that's the next method. You're right on track here. So if you wanted to remove by index, say, hey, I want to remove the thing that's at index 0, we use pop. So I'm going to put this back to C for cucumber so it doesn't crash. So we'll put a little note in here. If it's not in the list, it will crash. Here's the error message. I don't know if that's useful or not, but sure. And we'll go back to cucumbers. So say we wanted to get rid of bananas. That's at index 1, right? So I can say foods.pop 1. So pop removes by index or the last item if no index given. So you can also remove the last thing. If you just say pop, it'll remove the last item. Or you can say pop 1, it'll remove index 1. Then we can print foods. Print foods. We'll add fish again, and now we get bananas was removed, right? We popped 1, right? And we removed cucumbers. Oh, we appended food. Oh, I removed it, I added it, and then I removed cucumbers, and I printed it again, right? So yeah, so if you want to remove by index, you use pop. Pop's a common term. It doesn't mean a whole lot, but it pops it out, if that's helpful. Again, just go look it up. Right? There's a little table here of all the things you want here. Other fun things you can do with lists. You can add two lists together. It'll concatenate the two lists, right? Here's one list, here's another list. It'll stick them together here. You can get the length of a list. Like we got the length of a string, you can get the length of a list. How many items are there? You can get the smallest value in a list, or the largest value in the list, or the sum of the list, if they're numeric, right? If you want a specific value, you can use .index, or count. How many times does this particular value show up here? You can use count of a value here. So with my list, let's see, okay, there's foods, we printed out foods. So if I wanted to get the smallest food, doesn't really make a whole lot of sense, but I can say min of foods. So some of them are on the outside, others are list dot this. You're just gonna have to go look it up to get used to it. And sometimes you forget and it doesn't show up and you're like, oh, I used the wrong option. So the smallest food, now remember how characters are stored as numbers? So what do you think the smallest character is then? If we look back at that Unicode table, what do you think the smallest letter is? A, 65? That doesn't even have the number there, that's fine, but A is the smallest, but the digits are smaller than that. The punctuation is even smaller than that. So when we ask for the smallest value here, it's going to be, let's add fish, the one with the smallest first letter. So it looks at the first letter, and notice these are lowercase letters. Lowercase letters, remember, have their own set of values. They're higher than the uppercase letters. So the smallest lowercase letter, it's not super useful, but sure. Now we have the smallest food here. So this is, A is the smallest value for a letter, a character. A is bigger. I don't know, the lowercase ones are bigger, if that's helpful here. But if we want to have a list of numbers, right? So maybe we have a lotto ticket. Lotto ticket. What number should we put in the lotto ticket? What are your lucky numbers?
11.
11? 14, 8, 16, and 23. Okay, and then what's the Powerball number? If you want to play Powerball, that's a number 1 to 26. 2. Right? Sure. So now we have our lotto ticket. Now I can print the min of the lotto ticket. Here's the smallest number in the lotto ticket. Or I can print the sum of the lotto ticket here. Here's the sum of all the digits here. Or if I wanted the average value, that makes a whole lot of sense for a lotto ticket, but sure. Right, remember, average is the total divided by the number of values there. So I want the sum of the lotto ticket divided by the length of the lotto ticket. Right? I don't know why there's not a built-in average. Like Excel has an AVG function for average. Python doesn't. One of these days I'll try and convince them to add it in, but no one wants to listen to me. Right, so now we can do that for our lotto ticket here. And not very interesting, but our minimum value was 2. The sum was 74, and the average was 12.33333333, right? So 74 divided by 6, 4 divided by 6. That's the wrong answer there. 74 divided by 6. There we go. I was on the programmer calculator, and it lost my decimal places. Sometimes you get weird answers there. But it seems to check out. Python seems to do the math right. We could add them up ourselves if we wanted here, right? 25, 33, 43, 49, 69, 72, 74. Yeah, seems to check out. I figure it's pretty good at math, but it's always nice to double check, right? If you can't solve the problem in your head, you have no way of knowing if Python did it right. Maybe not in your head, but like on paper, right? Like for our party example here, you should be able to work this out on paper without any code, because that way you know how to check it, right? If you don't know what the answer is supposed to be, you've got no way of checking it, right? Make sense? And just a fun fact here, when guests come to a party, you probably don't, like if I say, hey, you're having a party, how many people are coming over? And you say 4 people, how many people are at the party? 5, because you're also at the party, right? Don't ghost your own party. That's just weird. Even if you're antisocial like I am, you still have to show up for a little while at least. Someone posted the funniest thing here. I should have grabbed a picture. I like posting stuff in the memes channel on my Discord server because it makes me happy. But it was like the balloons you can decorate, like give messages with all the like big golden balloons. It was please leave by 9, and the gold balloons on their wall. And like now I'm ready for my party, and I felt that. That's my kind of party. Okay, so lists, right? We can do some fun functions with lists here. They're sequence types, so we get out particular values. So tuples are almost exactly like lists, except they are not mutable. They are immutable here. Some people call them tuples. Some people call them tuples. I usually say tuples because I think that sounds better than tuple. I don't think there's a right answer here. But tuples use parentheses for values here. So after you buy a lotto ticket, it probably makes sense that you don't change your numbers, right? Like I could go and change the numbers. So I can say lotto ticket index of 2, and now we'll change that to 27 or something. You probably don't want someone to do that with their lotto ticket, right? So when we make things in code, we want them to kind of model real life. So if something shouldn't change in that sequence, don't let it change. Make it a tuple instead, and they can't change it, right? It just keeps them from trying to cheat with their lotto ticket here. Sure. So with a tuple, then, we might have, let's do, I don't know, how about the winning ticket then? Winning ticket is, and we'll use parentheses here for tuples. I don't know, 1, 2, 3, 4, 5, 6. That's a super interesting ticket here, but sure. Now we can do most of the things with this one here. We can't do all things here. So you can still use length, you can still use the indexing, but you can't assign stuff to it. So you can't change the value at a given index, just like with strings, right? I can't say, hey, I want the winning ticket index of 2 equals 27. Now it's going to crash here. It's even warning me, tuples don't support item assignment. Just like it said, strings don't support item assignment, right? This one doesn't work. Oh my goodness, there we go. Yeah.
Can you have a list of variables?
I'm sorry?
Can you have a list of variables?
Yes. Yeah, so you can put another variable in one of your lists.
Would you be able to change it then?
When you try and change it, it changes the value there. So if we had like, let's do names here. So we'll make a list of names. So we'll say names is list of name, comma, last name. So this is a good question here. So this is a list with variables. And now if I print names, it's going to change the value, or I'm sorry, it'll show me the value of names here, right? And then your question was, can I change the value? So if I say hey, names at 1, right, can I change the value here? So whatever I typed in was fine here, and now we'll say you don't get a last name. Let me use double quotes here because that makes life easier. Here. And we can print names, but now we print last name here. So let's do this as a formatted string here. So we'll do last name, see if it changed, right? So we're going to change what's in the list here. So favorite food, or add fish. All right, last name here, Chernesky. And then we get Eric Chernesky misspelled here, right? So we printed out the names, right? That's my list here. And then we said, okay, names of 1, you don't get a last name. And we printed names again. We got this. But now when I printed last name is still Chernesky. Now this comes down to strings being immutable, right? When I stored last name, Python said, hey, operating system, give me a place to store a bunch of letters. And last name points to that location. In my list, when I said, hey, change what the index 1 points at, it made a new list in memory, a new item in memory, and your list now points over here, but last name still points over here. We still have something looking over here. We didn't change the value of last name. Last name is still looking at Chernesky, or whatever they typed in here. So the list has been changed, but the value of last name has not.
So it doesn't change the value of the variable, it just changes the variable itself?
It changes what's in the list there. So it essentially swapped it for another variable.
Wow.
Yep. So now the list is different here. Let's do, now when we print, let's see, so print names, we'll do the last name here. Now if I change first name here, or just name here, right, to, we'll change it to Bob, and I print names. Now this is saying change the value that name points at. Name is still in the names list here. right? So now when I print out my names list here, I'm going to get Bob. Fish. I really should be able to spell my last name. That's sad here. Oh goodness, nope, I'm sorry, I did not. It gave me a copy, so even that didn't work here. I probably added it must have added a copy. That's interesting. Yeah, so when we tried to change the value of name and print names, it still changed. So I think what it stored then was what name pointed at that point in time. That's probably what happened. So even changing that variable isn't really working for us because we've got a copy of it in there. Yeah, Python's fun. Lots of fun stuff. Tuples. If you want, you can do these named tuples. Don't worry too much about this. We're not going to do anything with it for a while, but if you can go look it up, and it looks like some crazy things here. You have to import it. Sure, some people really like them. I'm not a big fan of it here, so I will just ignore them. But they do exist. All right, sets. We got a couple minutes left. We're doing good. So a set is different than a sequence. Remember, sets are like a collection. Right? You have one and only one of each thing. Right? If you want a set of stamps, you're not going to have the same stamp twice. Right? If you like to collect stamps, or I don't know, what things do you guys collect? Do you collect Pokemon? You don't have more than one of the same in your set here. You got to catch them all, but not duplicates. So unlike Pokemon Go, where you can have duplicates. So also it's unordered. So once you put something in a set, there's no order to it. So with our list, we said, hey, this is the first thing, it's always index 0. This is the second thing, it's always index 1. Sets aren't ordered. So we'll put a bunch of things in, and we might not get them back out in the same order. So that's just a fun fact there. So you can make sets with the set function, right? Or you can make them with the curly braces and comma separate your values. More than one way to do it here, to make a set. And now sets only have unique values. So if you try and add something to a set again with the add method, so it's not append because there's no order here. We just add something to a set. You can remove and pop. Pop, again, removes just a random value because there's no order to it. So pop is not very interesting for a set unless you want to like pick a number out of a bag or something. Like here, let me make a bunch of cards, a set of cards here for my deck, and pick a random one out. But remove by name and adding. So we can add items to a set. So if we want a set of values here, wow, we have like a bunch of lines of code already. Look at that, 123 lines. So we can use for set or set some values here. So let's make, is our Pokemon, right? And then we'll make a set here. So we've got Pikachu. Is it a C or a K? Wow, I really don't know how to spell that. Is it a K?
Yeah.
Pikachu. All right, there we go. And we might have Squirtle. Squirtle. Is there 2 T's in Squirtle? 1?
4.
All right, and what is it, Charmander? Right? And Bulbasaur. Bulbasaur. All right, I could probably remember more if I tried harder, but that's all I got at the moment here. So we've got our set of Pokemon here. We can print our Pokemon set. Or we could go add some Pokemon, so Pokemon.add. Let's add Eevee. Eevee's a cool one. Is there 2 E's, right, for Eevee?
Yeah.
Eevee, and then we can print our Pokemon. If we wanted to remove one, we use remove, right? So Pokemon remove, let's remove, let's get rid of Charmander. Poor Charmander. Oops, in quotes here, right? It tries to be helpful with quotes. All right, and then we'll print our Pokemon, right? And we can see we have our list here. We added in Eevee, and then we removed Charmander. So works very similar, but now if I wanted to add one that already exists here, so Pokemon.add, if I wanted to add Pikachu again,
They'll add it again. Right.
it doesn't error. But if I go print it, print Pokemon, Pikachu's not in here twice. And notice the order's weird, right? It's not the same order we gave it to, right? Because the order doesn't matter in sets. It's unordered here. So it won't crash. But nothing happens, right? We told it to add, but it didn't do anything here. So removing items, you can remove. You can get the length of a set. You can add sets together. You can add a value, remove a value, pop a value. You can clear the whole thing if you want here. A couple different options here. Other fun things you can do with sets when you start getting into discrete math. This will be more interesting here. We'll do intersections, unions, and differences of sets here. Right? The intersection is which ones do they have that are in both. The union is just stick them all together here without duplicates, right? Because they're sets. And difference is what is not in the first one, or what's in the first one that's not in the other ones. There's a specific order here. I always forget here how they work, right? So that's our sets. So we'll come back to dictionaries when we get back on Wednesday. So we'll have a little bit of practice with the first types here, and then we'll look at type conversions and binary, and we'll wrap it up on Wednesday. Sound good? All right, I'll see you over in lab in about 15 minutes over in HPEC 1190. Thanks, y'all.